Okay, so doing some stoichiometry work with solution. In an experiment to determine the concentration of a solution of hydrochloric acid, 15.5 mils of hydrochloric acid was neutralized by 25 mils of 0.055 molar solution of sodium carbonate. Okay, so write a balanced equation. So we've got hydrochloric acid plus sodium carbonate. And we know when we have an acid and a metal carbonate, we get a salt, we get water, and we get CO2 being formed. Okay, so what we have to do now is balance. So 2 sodiums, pop a 2 there, carbonates, okay. Gonna have to pop a 2 for the chlorides now. And let's count our carbons. So we've got 1, 3 oxygens, 1 carbon, 3 oxygens. So that looks pretty good to me. 2 hydrogens, 2 hydrogens. Awesome. All right, so B, determine the concentration of the hydrochloric acid. Okay, so hydrochloric acid here, we know our volume, and for the sodium carbonate, we know our volume and concentration. All right, awesome. So we know more about the sodium carbonate. Now, with any stoichiometry work, we always deal with moles. So just always remember that, because we use ratios, don't we, that we draw from the equation. We use these coefficients, and these coefficients speak of molar ratios. So we need to always talk about moles. So we have concentration value and a volume value. So we can use those two values to find the moles of sodium carbonate that I have. So concentration 0.055 times the volume in litres, 0.025. So let's find that value. So 0.055 times 0.025. So the mole value is 0.001375. Cool. Alrighty. So then we want to know information about hydrochloric acid. We know the mole value of sodium carbonate now. And so what we can do is use our molar ratios to find the mole of HCl. Okay. So, and then from there we can calculate its concentration. All right. So how do we do this? Moles of HCl. So we always look at our unknown coefficient over our known. Okay. So if you remember, we draw a line from what we do know to what we don't, pointy over non-pointy, or unknown over known times my known value. If you forget which one it is, unknown over known, you're always going to be multiplying by known, aren't you? So you always remember that. This is the molar ratio that you might get confused with. Is it the known concentration? Sorry, is it the known coefficient over the unknown coefficient? So always just remember that you're going to want to cancel out your known values, your known units, to get your unknown. Okay, so the known should always be the denominator. So molar ratio, always the unknown over the known, multiplied by the known value, the mole value that you know. So 0.001375 times 2, 0.00275. We can just see that it's double, yeah? And that's exactly what we've done. So we have double the amount of hydrochloric acid in mole values reacting with sodium carbonate. That's how many moles of hydrochloric acid are going to react. Okay? So we need to determine the concentration. So the concentration, C equals moles divided by volume in litres. So we have the mole value now. And what's our volume of hydrochloric acid? 15.5 divided by 1,000 So 0.0155. That is going to be our concentration. 275 divided by 0.10155. So our concentration is going to be 0.177 mole. Okay, that's it.